All right, we are recording. Hope everybody had a good week. This is the second half of chapter 9. Going to do a little review on internal rate of return and then go on to do some end of the chapter problems. The last questions end of the chapter 9 here are pretty much, you know, putting everything that we've learned together, and I'll show you some tricks so you can get to the answer a little quicker. All right, so let's just get straight to it. It is freezing here in the office, so I am I am struggling, but we'll see. We'll get through it. All right. Yeah, and there, at any point there's any questions, just let me know. Uh, and don't be afraid to just unmute and ask. That's what we want to do. All right. So the internal rate of return is what your project is proposed to give you back. So depending on your firm's required rate of return and the present value and payment numbers based off of a project or financial vehicle, you choose whether or not that project makes sense to you. So internal rate of return is a project or financing vehicle itself, and your internal rate of return, or your R, is the what your firm requires based off of its entire portfolio of projects and finance vehicles. All right, so calculation, it's pretty simple for net present value. It's a cumulative, there's a basic formula that we use. It's whatever that cash flow is for that time period divided by 1 plus the rate, raise it to the time period. So we'll do some of that at the end of the chapter question segment of the lecture, so you can see when you should do it based off of the way the question is asked. So we'll get into that. But remember this part: project is acceptable if the internal rate of return is greater than your firm's required rate of return, which we just label as R. This is a timeline version. So this is getting your internal rate of return for project S. And this is just saying we want to get the sum of all cash flows from year 0 to year 4. And then T is equal to 1 here because we're doing it in 1 year increments. All right. So that's how you read that. This is another way of putting it. So your future, your net present value is equal to 0 when your IRR is reached. So that means at what point does my net present value cross that boundary? And we'll show you some that 0 and net present value boundary. And that's asking, a project is good as long as the net present value is above 0. So right there at that greater than 0. So not equal to, but just greater than 0. It's acceptable. So that's your net, what your internal rate of return would be visualized in a graph. So I'll point that out when we hit that slide. You got a financial calculator, it'll ask you the sequence of cash flows, and then you just ask for the internal rate of return. So that's why I'm teaching you guys how to do this in Excel, so you don't have to spend $100 plus on a financial calculator. So the rationale again is the project internal rate of return going to increase my firm's bottom line? The answer is yes, only if it's greater than what my firm requires as a rate of return. So that's how you should think about that. So this goes back to last week, so we'll skip this part. But if the projects are independent, you're going to want to choose both. If they're mutually exclusive, you're going to want to choose the project that gives you the highest rate of return, internal rate of return. Okay, so now moving into what we call profiles. This is kind of what we would call a sensitivity analysis in statistics. But what we're saying is if we change the discount rate, what is the difference in net present values over the same amount of time per these changes in discount rate? So we'll do an end of the chapter question that details this so you guys can see how that works out, and we'll use the multiplier that we learned from last week to figure out net present values. So here's a visualization. Net present value is either 0 at this horizontal axis, or it's positive or negative. So anything that's below 0, we do not want to accept the project. Anything that's, we're not going to say at, but anything that's above 0, we want to accept the project. So right here, this is the threshold, the 0. So that's why this equation up here was set equal to 0. So we could find the maximum internal rate of return. But you're always going to want to choose something that's above 0. So just keep that in mind. And I'll show you how to calculate that at the end of the chapter. 2 reasons net present value profiles cross. One is scaling differences. Smaller project frees up funds at t equals 0 for the investment. The higher the opportunity cost, the more valuable these funds. Thus, R favors small projects. So that means we're saying, so the higher the opportunity cost, the more valuable those funds. That's saying smaller projects have a lower opportunity cost, everything else equal. So timing differences, projects with faster payback periods provides more cash flow in early years for the reinvestment. And we'll go over a few examples at the end of the chapter. So payback periods are something that we're going to go into detail here today. So reinvestment rate assumptions, net present value assumes reinvestment at R. So that's your company's required rate of return. And then internal rate of return assumes reinvestment at internal rate of return. So reinvest at opportunity cost, R is more realistic. So N, net present value method, is better. And that's saying we want to reinvest as long as the net present value is positive. So that's when you're doing it on reinvestment, always go with net present value because it'll give you a positive outcome. Now, getting into the nitty gritty, which we'll have an example of later, you'll see why net present value is the best bet. So net present value should be used to choose between mutually exclusive projects, ensures value is maximized. And that's just saying we want to go with the one that gives us the most money in the end. So multiple internal rate of returns. So suppose a project exists with the following cash flow pattern. You spend 1.6 million, you get 10 million the next year, and then you have to spend 10 million again in the second year after that. So 2 internal rate of returns exist for this project. And the reason is because you're crossing this 0 net present value line twice. So at each time you cross, you get an internal rate of return. So IRR of 25% here and an IRR of 400% here. And you can calculate this with this formula right here. And this is incremental, so we're using 1-year increments. And there'll be an example of that at the end of the chapter question. Better indicator of relative profitability, better for use in capital budgeting. So this is present value of cash flows equals the terminal value over 1 plus the modified internal rate of return. So modified internal rate of return takes into account present value of all outgoing and future value of all incoming. So that's it's complicated, but it's the more you, just follow the template that I'll show you at the end of the lecture here to get a better understanding. So we have cash inflows and cash outflows. That's what COF is and CIF. So the modified internal rate of return rule is a project is acceptable if your modified internal rate of return is greater than required rate of return by your firm. This is just showing how to calculate, and then you can use the build that we use also, and I'm gonna show you how to do it both ways, so you'll know how to do it either way, and whichever is easiest for you, then use that one. So we have so modified internal rate of return of L is 11%, and S is 11.5%. So 11.5 rounded up is greater than 11, and we choose the project that has the highest one if they're mutually exclusive. Now moving into payback periods. So we've covered internal rate of return and then modified internal rate of return, and now we're moving to payback period. Length of time it takes to recover the original cost of the investment from expected cash flows. So there's a number of ways to get there, but what we want to do is just have a table that shows us what the cash flows are and then adding them in over time. Which is what we're saying here. Payback decision rule: a project is acceptable if the payback period is less than the N here is the useful life of the project. So years determined by the firm versus useful life of the project, they're the same thing. So we'll use this example, one of these in the end of the chapter, but notice we have the cash flows over time and they're negative in the beginning. Negative in the initial cost, and then they go up over time. And then these are what we're expected to get in return over time. So to be able to get to these numbers down here, we're saying if we spend 3,000, then we're 3,000 in the hole to start. If we make 1,500 in the next year, we add that 1,500 to negative 3,000, and we're still negative 1,500 in the hole after year one. Year two, we make 1,200. So we add 1,200 to the negative 1,500. So after year two, we're still 300 in the hole. Then we add 800 to that, and we're positive 500. So your payback is going to happen between the time period where you're in the hole and you get back into the black. So to figure out the exact amount of time. So you know it's between year two and year three because you switch from negative to positive there. But this is how you do it. You just do payback period is equal to 2 years because it's not 3 years, but it's more than 2. So 2 plus, and then you want these numbers to be positive. So you just take whatever's in the parenthesis as the numerator, and then whatever number you have for the next year, net cash flow is the denominator. So we'll get into a pretty long example at the end of the lecture here, but that's how you do it. Oh, these are always going to be positive numbers, so just take the positive, the absolute value of any negative number. Any questions on any of that? I know that's a little, maybe going a little fast, but just let me know if you have any questions. All right, now discounted payback period is taken into account all of the present values of a series of cash flows. So if we're saying negative, so we're gonna make 1,500, then 1,200, then 800, then 300. We want to take into account that we're going to be provided a required rate of return, and then we discount this to that present value of future cash flows. So traditional payback period does not consider the time value of money. Discounted payback period equals the length of time it takes for a project's discounted present value of cash flows to repay the cost of investment. So that's what we're saying. Discounted project payback is less than the project's useful life. So we want to be able to pay it back before the useful life of the project is after that time period has been reached. So this is the same example, and we're saying, all right, if the I forgot what the discounted rate was, but there, see how this is, the discounted cash flow is less than the actual because they take into account the time value. So it switches the payback from 2.4 years to 3.2 years because we now have discounted payback value and cumulative discounted payback value that we're using. So these numbers are different, and it goes from negative to positive between year 3 and year 4. So there's a bunch of different budgeting methods to choose from. I'm trying to give you Excel problems so that you'll be able to quickly get to the answers. And they're more sophisticated today than they were 20, 30 years ago. And they use multiple techniques. So I'm trying to cover them all, but new ones are created frequently too. So just keep all that in mind. All right, now let's move into the assignments. So I'll open up an Excel here. So I am assigning 8, 13, 16, and 19. So we'll do number 9. I think I have it up here. Yeah. All right. So number 9 is saying construct a net present value profile for capital budgeting projects that cost $64,000 and is expected to generate $18,200 per year for the next 5 years. Using the NPV profile, determine the project's internal rate of return, net present value at required rates of return equal to 10%, 13%, and 15%. So again, this is a sensitivity analysis that we're asking for. So it's asking for multiple different percentages. So we want to create a table that will take into account every percent from 0% down to something above 15%. So we can go like 18%, something like that. So that's just a shortcut. So do 2 and then drag down like I just did. Make sure that you guys see that if you don't know how to do that. Multiply, I think that's right, multiplier. So again, if the rate's 0, the multiplier will be 0. And our net present value is let's see here. Cost 64,000 is expected to generate 18,000. One second. For the next 5 years, determine internal rate of return. Then net present value. So we want to find an NPV at this one, 13 and 15%. So we're looking for net present value. So again, the multiplier is, let's see the formula. So remember, here we go, right here. So we have the 1 minus 1 divided by 1 plus the rate, 2, 5. So all of these are going to be 5 years because that's stated right here, per year for the next 5 years. And then divided by your rate. So you can use this as a placeholder. So if I were to hit enter, so it shows this. And then you can drag that down all the way because it's taken into account its accompanying percentage. And that's just for your multiplier for net present value. So our actual net present value for our top one here is just going to be, so it costs 64,000. And then we add in 18,200 for 5 years. So that one just calculate on its own because it's an easier way to do that. But then from here on out, you can say equals negative 64,000 plus 18,200 to the multiplier. And then let's see. Yeah, and we'll drag that all the way down and make all those dollars. And we can say that our internal rate of return is going to be 13% because this is pretty close to hitting 0 based off of how big the actual numbers we're working with are, 18,200. So yeah, we can call 13% our actual IR, and that'll be fine for a something that's really close to 0 based off of the numbers that are before and after. So if it's like times 10 or 100. That, you know, it's more than 2 orders of magnitude difference. So that'll be all right. So I'm sorry, I'm blabbing. Just highlight the percentage that's closest to 0. But if this were negative, then you'd know that it's between 12 and 13%. But this is so close to 0 that we know it's like 13.01%. So that'll be fine. All right, let's continue here. Let's keep going. So using a required rate of return equal to 12%. So we can put that in there. Compute the modified internal rate of return of a project that costs $82,000 and is expected to generate $35,000, $70,000, and negative $10,450 respectively during the next 3 years. So then we have year 0, 1, 2, 3. And then we want, remember, we want to have cash flows. And we want to have present value of outflows and future value of inflows. Taking into account 3-year period. So I'll show you how to calculate these. It's not straightforward, but you'll get used to it as you do this. 82,000. Then we had 35,000, 70,000. These are numbers right out of the question here. Negative 10,450. All right, so outflows are what you're spending. So there are 2 outflows, the initial year and year 3. So we want to be able to get the present value of those. Since this is happening right now, that stays the same. Oops. But here we want to say we want to get the present value of the cash flow that's 3 years out. So we go equals this cash flow divided by 1 plus rate raised to the 3. That's negative 7,438.1. And then we want to get a total here and add these 2 together. And this is so we can calculate modified internal rate of return later on. So we need to use this number in our calculations. All right, now inflows, we have 35,000 and 70,000. So what we want to do here is 2 things. We want to get the future value, so we're not dividing by 1 plus the rate raised to the time, we're multiplying. So we got to go equals 35,000 times 1 plus rate raised. Now here's the tricky part. So if we're in the first year and we're trying to get the future value of what it would be in 3 years, we have to subtract these 2. So we have to do this. This is part of you know, getting not only getting it right, but this is algebra. So we have to be able to say, all right, so 1 year out, we're still 2 years away. So we have to calculate that into our question there. So then you get 43,904. And then the same type of deal for here. You have to have equals 70,000 multiplied by 1 plus the rate, and then raise to the, now we have 3 minus 0. So 78,400, and then add these up. All right, so now there's a couple of ways to do this. And one of them can be our regular way. So this is what we call our regular way by doing the build. And this is to find out modified internal rate of return. So now we have 3 years looking for this. So present value is this, your present value. So this number equals this. Payment is 0, payment type 0. Future value is this number. And then we have equals rates. Per payment, present value. Future value. And then always take it out a little bit. All right, so 11%, and that's your MIR. And we'll leave it with that one because we're used to doing it that way. But just remember how to get your present values and your future values. So these are saying how many years do I have to go until I get to the 3rd year. This is to the 3rd year. And if this were longer, then you'd use whatever the last year was and subtract whatever year you're currently. All right, so that one was a little more difficult, but if it asks, should the firm purchase this project, the answer is no. And the answer is no because your modified internal rate of return is less than your firm's required rate of return. So this number would have to be greater than 12% for it to be acceptable. So just keep that part in mind when you're doing calculation. All right, let's do number 11. What is the internal rate of return for a project that costs $5,500 and is expected to generate $1,800 per year for the next 4 years? So if a firm's required rate of return is 8%, what is the project's modified internal rate of return? Should the firm purchase the project? So here we want to do, let's use our regular build here so we can use this to get a few pieces that we need. So first off, we're saying find the internal rate of return for a project based on these parameters. So we have 4 years. We're looking for internal rate of return. Present value is negative 5,500. Payment is 1,800. And future value is 0. So equals rate per present value, future value. Bump it up. So 11.72 is your internal rate of return. But now we need, if we're going to get, so we need to find out what the future value is of $1,800 per year at a required rate of return of 8%. So to do that, we need to do another bill. So now we're looking for future value. And the number is 4 again. So you always need your future value and your present value to figure out modified internal rate of return. So that's just always get those numbers. So we do have present value, so we need to get future value of this $1,800 payment over 4 years at an 8% premium. So this is our rate. Present value stays the same. Oh, excuse me while we're only calculating the payments. So this is saying what is the future value of 4 payments at 8%? That's what we're asking. So rate, years, payment, present value, type. And so we always want our future value numbers to be positive. Since we can't denote which way we're looking at it from based on inputting numbers, we can do 2 things here. We can say we can change this to negative, saying that, okay, if I'm paying out $1,800 4 years at 8%, how much would I pay out altogether? And then that would give you the positive number that you need for future value. Or you can say, undo that, just take the positive number of this output. So just remember that it needs to be positive. So that I don't know what the absolute value key, where the absolute value key is, but always take the absolute value of a future value if the payment is positive. Okay. All right, but for this case, we're going to say the absolute value. So that's when I put something in in between 2 vertical bars like that, you want to use the positive. And then I'll just put, so that's equal to negative this. All right, now we can solve for modified internal rate of return. So we're still going with 4 years. We're solving for this. This is now right here. Oops. Excuse me, let me put it over here. Present value is negative 5,500. We don't need to include the payments in this one because we have calculated the future value of all the payments. So 10.20%. Do we accept this project? Yes, we do, because 10.2 is greater than 8%. So all of these are good. That's a little bit more complicated because of this point right here. But just remember, if the payment is positive, your future value, you want to take the absolute value because it'll be positive. Yeah. But that can throw some people off because that's the way we calculate it, and what's going in the door and what's going out the door. All right, let's do one more and then let's call it a night. All right, so let's do number 14. Compute the traditional payback period for a project that costs $64,000 is expected to generate $16,000 per year for the next 6 years. If a firm's required rate of return is 12%, what is the project's discounted payback period? Should the project be purchased? So we need to do both. We need to do what's the regular payback and what's the discounted payback. So let's do the first one. Regular payback. Six years. Then we need what are our cash flows and what are the sum of our cash flows. Because this will give us when we go from negative to positive. All right, so our cash flows are negative 64,000, and then we make 16,000 per year for the next 6 years. And then we're saying, so the first year is going to be to that, and the second year is going to be 2 plus. Remember how I did that? So then you can drag it down. So just drag that one over so they're the same. Then it's this plus this. And then you can drag that down. All right, so we have an answer. So 4 years on that one because it equals exactly 0. So that's our payback of 0. Now, getting discounted payback, we have to use the same concept here, but we got to take time value of each one. So I'm going to do it the long way, but you guys, if you know, if you can handle your own shortcuts, please do. But I want everyone to see how to do this the long way. All right, now we have present value of cash flows. That one's going to stay the same. But now here we have 6 divided by 1 plus. Oh, oops. Forgot. So our rate is 12%. And then this just calculated it out. Plus the rate raised to the time. And now see if you were to do this. Oops. It's not going to work. So you have to be able to calculate it. One plus rate raise year. See that? See, that's not going to work. And that's not going to work. So you got to do each one. The rate raised to plus the rate. And then equals doing these by hand. And then you want to be able to equals this plus this, then you can drag this. So we know that's our break-even period is in between year 5 and year 6 because we go from negative to positive, but to figure out exactly what our MIRR is, we do, our discounted payback period, we do a calculation. So we know we have 5, so it's going to be greater than 5 and less than 6. So to figure out what the decimal is, we take the absolute value, so that's equal to absolute value of this number, so 6323.58 divided by this number, our last present value of cash flow for the final year. And then we got to add 5 to that, so equals 5 plus these. So that's your payback period, 5.78 years. So that is how that is done. So remember, you're taking this absolute value of that, and dividing it by this. All right. And that's your discounted payback. So you go from 4 years to 5.78 years. It makes a huge difference. You can see that. All right, let me just go over one more. And I won't write anything down. I'll just cover this conceptually and read some conceptual things here. So you're looking at reports as a manager, and you have interns that do some data. And we get the following. The CFO of Horatio's Hotels gave 3 interns 3 different independent projects to evaluate. The following are the results of their analysis. Albert, so project life, net present value, internal rate of return, discounted payback period. So project's useful life is 7 years. So what matters to that is discounted payback period. Payback period is less than the useful life, then we want to accept the project. But then there's also, if the NPV is positive, we want to accept the project, and then if the internal rate of return is greater than our rate of return our required rate of return by the firm. And that isn't explicitly stated, so we have to make some conclusions based on what we see. So Josie's 6 years, project's useful life, net present value is negative, IRR is 8, discounted payback is 5.8. We reject based on net present value. But there is a discrepancy here, and we'll get into that. Kenny, project life 10 years, discounted payback 9.6, IRR 10%, and net present value is positive. So the CFO agrees with the final accept reject decisions each intern made, but spotted an error in the numbers reported by one of the interns. Which intern's report has the error? Does the information given here provide an indication of the required rate of return? So yes on both counts. So if we have a negative net present value, we assume that the rate of return is going to be less than the internal rate of return. So also, we have some rules of thumb that we want to abide by. So I'll read through this real quick. Net present value greater than 0, we thumbs up on that. Internal rate of return greater than the required rate of return, thumbs up. Discounted payback is less than the project life, then we want a thumbs up on it. So the discounted payback less than the project life, but we're rejecting it. So that's where the discrepancy is there is an error in this calculation because we always want to accept projects that have a discounted payback less than the project's life. So although the firm required a rate of return is not given, the other two relationships do indeed exist because Albert and Kenny seem to have reported correct results. Josie's report must have the error. So here's the rule of thumb that you want to keep in mind. If a project is not acceptable, the net present value is less than 0 and discounted payback period is greater than the life's project of life. For Josie's project, she reported a net present value less than 0, which is correct. But the number that she reports, the project discounted payback period of 5.8 years, which is less than 6 years. This is an error because when net present value is less than 0, the discounted payback period is always going to be greater than the project's life, which means that the discounted payback period is an error that she reported. So this should be above 6. Now, what can we gather from the what's the required rate of return? So what we know is if so 12% was accepted for internal rate and 10% was accepted. So we know that it's somewhere below 10%. However, 8% was rejected. So given the error in discounted payback, we know that this number is correct and this number is correct. So what we can conclude is that our required rate of return is in between 8% and 10%. That's what we can conclude from the data. So just that's how you work through these things conceptually, but always know that if net present value is negative, the payback period's always going to be bigger than the project's life. All right, so that'll be it for today. There is questions due, and then everybody look at your case study, pick a project, pick a company, and I'll send out an email later this week asking for your guys' companies so I can see if there's any duplicates coming in. All right, and then discussion question due tonight, and do the teacher evaluation. You know, I know it's an online class, but these Zoom meetings are meant to be helpful and even more helpful than in the beginning when they were time limited. So thank you all for doing good, and email me if you guys have any questions. All right. And have a good night.